Hello, fellow. My name is James Owusu-Appiah, and I believe in innovation and doing things differently. This video has been prepared for you to guide you through some well-known concepts that will aid your studies and preparations towards exam. Due to COVID, we cannot meet in person to discuss, so I hope this video finds you well and helps you achieve excellence. Thank you.
Hello everyone. Please, today we will be talking about superposition theorem. What is the superposition theorem? The superposition theorem says that the current through any element or the voltage across any element in a multiple source linear circuit can be found by taking the algebraic sum of the current through or the voltage across that element due to each individual source acting alone. What we mean is, you consider each source, either it is a current source or a voltage source, acting alone. So you consider a single source at a time. So below are the procedures for you to follow when you are using the superposition theorem. Step 1. Find the response in a particular branch by considering one independent source and eliminating the remaining independent sources present in the network. What we mean is, you consider only one source. If it's a current source, you consider it acting alone. But remember, this source must be independent. So step 2 says, repeat step 1 for all independent sources present in the network. And step 3 says, add all the responses in order to get the overall response in a particular branch when all independent sources are present in the network. Note the direction of each response and note the sign. We are noting the sign because our addition at the end of everything will be algebraic. And remember, we said independent sources because for dependent sources we can't take them out from the circuit when we are applying superposition theorem. So remember, we are dealing with independent sources. Yeah, please keep that in mind. We are dealing with independent sources. So let's take an example. Consider this circuit below. Provided we are required to find the current flowing through the 20 ohm resistor using the superposition theorem. How do we do it then? Now, we want to consider the 20 volt resistor acting alone. In this case, we have to open the 4 ampere current source. Remember, the 4 ampere current source here is independent, so we can take it out from the circuit. And to take it out from the circuit, we have to open it. So this is what we will get when we open the current source. Yeah. When we get this circuit, we can see that the 10 ohm here and the 20 ohm here are in series, so we can add them and we'll get 30 ohm. So they say like this. We can also see that this 30 ohm here is in parallel with this 10, and the resultant will be in series with the 5 here. This 30 is in parallel with this 10 ohm, and the resultant is in series with this 5. That will give you the total resistance in the circuit. So we get something like this: 10 in parallel with 30 in series with 5. So we get 10 times 30 over 10 plus 30 plus 5. You get it? So we get 12.5 as the total resistance. We get 10 times 30 over 10 plus 30 plus 5, giving us the total resistance in the circuit. Now, we also see that the total current through the circuit, which is IT, will be equal to the total voltage over the total resistance. We can also remember that our total resistance was 12.5 ohm, and from the circuit, the total voltage is 20 volts. So, we now have our total current to be 20 volt over 12.5, giving us 1.6 ampere. So, if we call the current I prime, being the current flowing through the 30 ohm, but before that, we have to remember that this 30 ohm was obtained from the 10 ohm and the 20 ohm being in series, which means the current flowing through that 30 ohm is the same as the current flowing through that 20 ohm we are considering. So from the current division rule and looking at this circuit here, we know that this 10 is in parallel with this 30. So if you want to find the current flowing through this 30, then it will be this resistor here, this resistance here, 10 over 30 plus 10 times the current flowing through. And we know that this current here flowing through this node here is the current from the source, which we found to be 1.6 ampere from this division. So our I prime will be 10 over 10 plus 30 times 1.6. So we get our I prime to be 0.4 ampere, and this I prime is the current flowing through the 20 ohm resistor when the voltage source is acting alone. Please take note that I'm saying I prime is the current flowing through the 20 ohm because the 30 ohm is a resistance value obtained from the addition of the 20 ohm and the 10 ohm. Because they are in series, the current flowing through them is the same. That's why I'm saying that the current 0.4 ampere is the same as the current flowing through the 20 ohm resistor when the 20 volt voltage source is considered to be acting alone. So after this, what do we do next? We consider our current source acting alone. To do that, we short the voltage source. Remember, our voltage source was somewhere here. We short it to remove it from the circuit. When we do so, you will see that this 5 ohm here is in parallel with this 10 ohm, and the resultant will be in series with this 10 ohm here. What I'm talking about is the 5 is in parallel with the 10, and that one will give us 10 on 3. This is the value here, and this 10 on 3 is in series with this 10. What I meant was this 10, yeah. So this 10 on 3 is in series with this 10. So the circuit will reduce to something like this: 10 on 3 plus 10, which is 40 on 3, in parallel with the 20. And now our source is a current source of value 4 amperes. What do we do next? You can see that since the resistors are connected in parallel, then we can use the current division rule to find the current flowing through our 20 ohm resistor here. To do that, it's very simple. It will be 40 on 3 over 40 on 3 plus 20 times this 4 ampere here. Yeah, this is what I just said, and you will get 1.6 ampere. This 1.6 ampere is flowing in the downward direction because the current will flow to this node, and then it will split. One will go here and one will go here, so our value will be positive. Remember also the terminal of the voltage source. When it reaches here, the current is in this direction. So what it means is the current from the current source and the current from the voltage source are in the same direction. So after finding this current through the 20 ohm using the current division rule, this we get 1.6 ampere. This 1.6 ampere should then be added to the 0.4 ampere that we found to find the total current flowing through that resistor, the 20 ohm, when the two sources are working together. That's why I said I20 here, that's the current flowing through the 20 ohm resistor, is equal to I prime plus I prime. Remember, I prime was the current flowing through the 20 ohm resistor when the voltage source is acting alone, and I prime is the current flowing through the 20 ohm resistor when the current source is acting alone. So we add the two, and then we find our I20, which is the current flowing through the 20 ohm resistor when both sources are acting alone. Remember, if the direction of any of the current were different or was opposite to the other, then we subtract. But here they were all flowing in the same direction, which means we have to add them. So the total current flowing through the 20 ohm resistor when the two sources, being the current source and the voltage source, acting together is 2 ampere. Thank you for your time. Remember, this is a JOA initiative. Thank you for your time.